Okay, again, we asked you to write the logarithmic form of the given exponential equations. These problems often I can recognize and say, oh yeah, 10 to the second power. That really is equal to 100. I get that. But now to write it in its logarithmic form, remember a logarithm is an exponent. The exponent for this problem is the number 2. That's what's all alone. Then I write the word log. My base is a 10, and I'll put the 100 in this other spot. So 10 gets raised to the second power in order to get 100. That's what this sentence is saying. Would you always look at this and write the exponent down all by itself, and then would you put the base as a little number? So the base is 16. It's supposed to be low here. So it's the log of 8, where the base is 16, is equal to 3/4, because 16 to the 3/4 power would be equal to 8. Please remember that there's always extra practice problems in these videos, and so what I wish for you to do is to go ahead and write down your answers to the next 3 problems, and then just check them real quick by scanning through the video quickly to see how you did. So I'll go ahead and write the answers to these next 3 problems. You pause so you can do them. So my exponent is all alone. My base is 4. Of 1 over 1024. My exponent is all alone. My base is the little letter p, log of v, where the base is p. My exponent is all alone. My base is the little letter e, which is a number, and the 0.0183. Would you look on your calculator now, please? There's an log key in the left column, and below that is an ln key. It probably looks like a straight letter, a line for a lowercase ln. Do you see this log base e? That is the natural logarithm. So log base e means ln is what it means. So if you hit your ln key of 0.0183 right now, it should give you an answer of a -4, or relatively close to a -4. I'm going to try it real quick. Yeah, it's close to a -4. Beyond the 10,000ths place, there's some decimal value, but pretty doggone close. Would you be able to go backwards? And sometimes this is a little bit easier for people. So here's my base, and that's my exponent. So 7 gets raised to that power to get 10. It's not like I know what the answer is right now for h. I could type it on my, don't forget, you could type that on your calculator by the change of base formula. You could type log of 10 divided by log of 7, and that would actually give you the exponent here that you'd raise 7 to get 10, and that exponent can't be much more than 1, because 7 to the first is 7. So it's probably 1 point, whatever. But remember, I'm just trying to go to write these in exponential form because they were given in logarithmic form. So here my base is 6. This is my exponent. 6 to the first power is equal to 6. And often you can say, yeah, I get this. They make sense. Again, do the next 3 problems, pause the video, and then come back and see what I got. So here, 10 to the -2 is equal to 0.01. And sure enough it is, because I know 10 to the -2 is 1 over 10 squared, and 1 over 10 squared is 1/100th, and 1/100th is 0.01 because this is in the 100th spot. So it makes sense. Even this one, I can check it. Check and see if 10 to the 0.4771 power is really equal to 3. You can type it on your calculator. Here, b to the 23rd power is equal to n. Nothing I can check there. I'm just trying to get it from Spanish to English is all. All right, let's see. Finally, as you conclude your work in this section, your homework is just going to ask that you try to interpret the answers based on your being able to understand this Spanish form and putting this into English form in order to find the answer. So the answer for x, the value for x for this one is 16, because it's asking us to take base of 4 and square it and get 16. If you write this one down in English, you can either look at it and say, oh yeah, I think 4 is raised to the third power and gets us 64. Or if you can't just think of that, you could take the cubed root of both sides of this, but that would mean you'd have to go use your math key on your calculator. So again, your math key. And then after you hit that math key, probably the fourth menu item is the cubed root of a number, and you'd put in that 64, and it would give you the answer of 4. Okay, so here, 5 gets raised to what power in order to get 5? And you would just say to me, x has got to equal 1. No math work really here. 4 to what power is equal to 16? Oh yeah, I just got to square 4. So x is equal to 2 in order to get 16. X to the first power is equal to 7. Oh, well that just means x is 7. Here, base of 9 to the first power. Again, hopefully you've paused this video and you're not just watching it and you're actually doing them. 9 to the first is equal to x. Therefore, x is 9. 3 to the negative 2 is equal to x. I prefer you to remember that that's 1 over 3 to the positive 2, and that's 1 over 9 versus just typing it. Here, 32 to the 2/5 power is your answer for x. So if you're going to do this on your calculator, you're going to have to go 32. You're going to have to hit that caret key. You're going to have to open the parentheses, really, really important, 2 divided by 5, and close parentheses. And I believe it should give us an answer of 4, because 32 to the 2/5 power also means 32 to the 1/5 squared. And I happen to know that the 5th root of 32 is 2. And 2 squared is 4. So I can get that without using my calculator if I understand these fractional exponents. Finally, please notice and remember that 10 has to be raised to the 0 power in order to get 1. 10 has to be raised to the first power in order to get 10. 10 has to be raised to the second power. 10 squared gives you 100. 10 cubed gives you 1,000. 10 to the fourth power gives you 10,000. And as we use this, like we're going to use this in class with some Richter scale problems, and when you tell me your answers, I'm going to be able to say, hey, your answer should be between 2 and 3 because you're looking for a number like the log of 256. Well, if the log of 100 is 2, and the log of 1,000 is 3. My brain is saying if I'm asking you for the log of 256, I'm going to type it, that answer should be between 1 and 2, and the log of 256, I'm sorry, between 2 and 3, and the log of 256 turns out to be 2.408. It is not a proportional thing. Please don't think that that's the case, but do recognize that the log of a number that's in this vicinity would be between 2 and 3. We've kind of, section 2 was kind of a, let's understand the language of logarithms, and then let's use it in our next section, chapter 13, section 3, to understand how to manipulate logarithms, and then to apply them in the section after that.